Hello, I'm Hannah Donner with the Collaborative on Health and the Environment. She enjoys bringing you the latest environmental health science through our partnerships, calls, webinars, science serves, publications, and social media. I would like to welcome everyone to today's CHE EDC Strategies Partnership webinar. This is the fourth webinar in our ongoing series on Pfas science and policy. Webinar today is titled Throwaway Packaging, Forever Chemicals, European-wide survey of PFAS in disposable food packaging and tableware, and efforts to phase it out at top US grocery and fast food chains. Our moderator is Shannon Jensen, founder and executive director of Health and Environment Alliance, or HEAL. Shannon has 20 plus years of experience in environmental health issues. She's been an official member of the World Health Organization's European Environment and Health Governance, representing the health sector since 2000, contributing to the WHO, or World Health Organization's Chemicals and Health Working Group, and is a member of the World Health Organization Advisory Council on Non-Communicable Diseases, NCDs. She has been on the steering committee of IPEN, or the International Pollutants Elimination Network, since 2006 to contribute health engagement expertise and EU policy. HEAL provides the secretariat of the EDC Free Europe campaign, in which Ms. Jensen has played a leadership role in creating and expanding to weigh in on and advocate for health protective EU and national policies on endocrine disrupting chemicals. We will leave time following the presentation for a brief Q&A session. You may type in questions to the Q&A feature available on the menu bar at the top of our window at any point during the presentation. After the presentations, our moderator will read out questions for our speakers to respond to. We'll get to as many comments and questions as we can during the Q&A period. For those of you who have called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone in the webinar right now is muted with the exception of our moderator and our speakers. The webinar is scheduled to last for 60 minutes and is being recorded for our call and webinar archive. With that, I'll turn things over to you, Shannon.
Thank you very much, Hannah. It's great to be here today, and we're going to unwrap some hard truths about our current dependency on disposable food packaging and hear about policy and market initiatives to reduce exposure and the risk of health impacts from both sides of the Atlantic. We will explore in this webinar PFAS in food packaging and alternatives for phasing it out. I'm really delighted to introduce our three speakers for today's webinar. First of all, we have Jitka Strakova, who is a global researcher at the International Pollutants Elimination Network, IPEN. And for the past 15 years, Jitka has worked as a volunteer, a local campaigner, and later as a coordinator of international projects and as a research advisor in Arnica, the Czech-based NGO, and has been involved in conducting several studies on persistent organic pollutants, or POPs, in products, waste, and the environment. Jitka authored the report that she will be presenting today, and she's also authored earlier studies on recycling brominated flame retardants into new products. So welcome, Jitka. Our second speaker is Julie Schneider, who is a campaigner at ChemTrust, which is a charity working to prevent human-made chemicals from causing long-term damages to humans and wildlife. Her work focuses on persistent synthetic chemicals, in particular PFAS. She is the author of the 2019 ChemTrust report, PFAS, the Forever Chemicals, Invisible Threats from Persistent Chemicals. And she's also the co-author of the report they will present together today. Welcome, Julie. And the third speaker is Liz Hitchcock, who is the director of Safer Chemicals Healthy Families. And she coordinates work with partner organizations and leads advocacy efforts on Capitol Hill and at the EPA and other federal agencies. Previously, she was the public health advocate for the US Public Interest Research Group and has led campaigns on environmental health issues, including product safety, chemical policy reform, chemical facility security, and food safety. So welcome, Liz, and I'm really excited to hear all three of you today. And with that, I would like to give the floor to Julie, who will begin the first presentation.
Thank you very much, Jenna. So I hope you can all hear me. Yes. So thank you so much for giving us the opportunity to present our study today on throwaway packaging, forever chemical, European-wide survey of PFAS in food packaging, disposable food packaging and tableware in Europe. And before starting this presentation, I wanted to acknowledge our third author, Natasha Signotti from HEAL. We think of you, Natasha. And also mention that uh, this study was a collaborative effort between 9 civil society organizations, which are listed on this slide for your information. So for the presentation, we will share it with Jitka. So I will start by presenting the background of this study, and then Jitka will present the scope and methodology, as well as results and interpretation. And then I will come back to wrap the presentation with a key conclusion and recommendation. So a bit of background for this study. So the Pfas, the pair and polyfluoroalkyl substances you might have heard of, it's a very large chemical family of over 5,000 chemical, 9,000 depending how you count them. And they are used in many industrial and consumer product applications, such as in cosmetics and electronics, in textile and in food packaging that we'll discuss today. But they are also found everywhere around the world. They are found from the ice sheet in the Arctic to raindrops in the US, as well as in drinking water in many places around the world. And they're also found in the blood of most people when they are being tested to check for PFAS, as well as in breast milk. And PFAS also in wildlife. So really the contamination with PFAS is global and pervasive. And we think there is really an urgency to stop the accumulation of PFAS in the environment and our bodies. Because PFAS, the forever chemicals, they are the most persistent synthetic chemicals known to date. So which means that if we keep emitting them in the environment, the level will keep increasing with time. And we know from study that a number of PFAS are related to really adverse effect on impact on our health, like impact on the hormone system, on the reproductive or immune system, and can lead to development of certain cancer. And also worryingly, there are research being published all the time with new information on PFAS. And the more we learn about this chemical, about their impact on human health and the environment, the more concerning it is. So for our study, we focused on PFAS in food packaging. So why did we choose that? So PFAS are used in food packaging because they have the ability to repel both water and grease, so which makes paper grease-proof, for instance, or cardboard grease-proof. But here is something really important to highlight is that this immense contrast there is between the extreme persistence of this chemical and the single-use nature of this product. And because with this product, which are high turnover, produced in high volume, there is risk to emission in the environment at different stage of their life cycle, starting at production stage and also at disposal. And this contributes to increase the pollution in the environment of PFAS, which eventually leads to more exposure for people and wildlife through, for instance, consumption of contaminated drinking water. But also the PFAS in food packaging, we know from study that some of them can migrate from the packaging into the food. And so this means that people can be directly exposed to the PFAS if the food have been contaminated in this way. So for our study here, our aim first was to collect evidence regarding the intentional use of this chemical of PFAS in disposable food packaging on the European market. But we also wanted to look at what is the background level of contamination in food packaging, which has not been intentionally treated with PFAS. So we selected some samples for this purpose. And we also wanted to generate some new in vitro toxicological data regarding PFAS for consumer products. And these are data which are quite scarce in the scientific literature so far. Ultimately, the aim of the study was to gather evidence to support strong regulation on PFAS and also to engage with companies to move for them to move away from the use of PFAS in their products and also to raise awareness in the public domain. So I will now hand over to Jitka that will present the scope, methodology, and result of this study.
Mhm.
Jitka, I will pass the slide for you.
Thank you very much, Julie, for this introduction to our study. We can go to the next slide. So in total, it was 99 samples of disposable food packaging and tableware collected in supermarkets, takeaways, and e-shops in 6 different European countries for our study. All samples were collected in late 2020, and to illustrate 3 categories of samples collected, you may see the pictures. First category included plant fiber products, which are basically labeled or understood as compostable. Second category included paper takeaway packaging for fatty food. And third category included other paper and board packaging, which is not used for packing fatty food. This category included, for example, shopping bags, table napkins, or cardboard boxes for cereals and spaghetti. Next one. With the 99 samples collected, we performed a simple do-it-yourself test, which is known as bead test. With this test, you can very simply at your home or at your office drip droplet of olive oil on the surface of the sample and observe if the bead is being formed on the surface. This formation of bead is a typical characteristic of Pfas. So if we see a bead of olive oil on the surface, we can interpret this observation as intentional treatment of the material by Pfas. If opposite is happening, if oil is spreading or soaking, we expect that there was no Pfas intentionally treated to provide oil repellent of these samples. So for our further lab analysis, we selected samples of both categories, oil beading or spreading and soaking, first to understand intentional PFAS treatment and also background contamination levels. Next one. On 42 selected samples, chemical analysis of total organic fluorine and specific analysis of 55 targeted PFAS was performed in laboratories in Denmark and in the Czech Republic. Total organic fluorine analysis is basically understood as proxy for total PFAS content, as this method includes the step of full combustion of all PFAS compounds, included fluorinated polymers. With the second method, which quantifies and detects specific PFAS compounds, those PFAS are being extracted with a solvent, and this solvent doesn't allow detection of polymeric PFAS presented in the sample. With using both of those methods, total organic fluorine and specific targeted PFAS, we were able also to calculate fluorine mass balance to understand how much of the total fluorine is accounted for the specific target PFAS. Next one, please. Total organic fluorine analysis was actually originally performed or developed for Danish authorities to test compliance with their ban on paper and board food contact materials. This legislation sets indicator value of 20 milligram per kilogram total organic fluorine dried white, and all the paper and board items which exceed the value of 20 ppm are considered to be intentionally treated with PFAS and are not compliant with the legislation. So obviously on this picture, the packaging reaching 340 microgram per kilogram total organic fluorine, this sample would not be compliant with Danish legislation, but the result would be likely accompanied with supplier declaration. Next one. The last but not the least step of our chemical analysis was bioanalytical method on 17 selected samples of extract. And this method uses the knowledge that thyroid hormones are being transported in the blood bound to transport proteins. Yeah, so this transport protein helps to transport thyroid hormones to target organs. But PFAS compete with those thyroid hormones for binding sites. Yeah, so in this method, we basically measure the amount of thyroid hormones bound and unbound to the transport proteins. Next slide. And I am happy to show you results and some of the interpretation of the results which we have got. Next one, Julie. So with the total organic fluorine results and with the beading test, we were able to group our samples into 3 different categories. First, oil beading compostable. Second, oil beading takeaway papers. I will just remind you that oil beading is being interpreted as intentional treatment of PFAS. And then the third group of oil spreading and soaking paper and board samples. Next one. Oil beading test very well reflected total organic fluorine concentrations measured in our samples. Basically, all of our oil beading samples had total organic fluorine levels above the Danish indicator value of 20 ppm. Yeah, so on this figure you may see the yellow box and whisker plot showing ranges and median of the total organic fluorine concentration, clearly illustrating that the compostable items which are displayed in this yellow color have the highest measured concentration of total organic fluorine. What's also interesting to see is the little blue box and whisker plot, which is category of oil spreading and soaking paper and board samples, which were not intentionally treated by PFAS, but there are PFAS occurring as a background contamination. And we conclude that those contaminations likely come from recycled paper, but they may also come from contaminated water or contaminated machinery and other sources. Next one. With the targeted PFAS analysis, we identified that it's mainly 6,2-fluorotelomere alcohol occurring across our sampled categories. This 6,2-fluorotelomere alcohol was detected in oil beading compostables and in the majority of the 2 second and third category. This fluorotelomere alcohol is basically impurity which is frequently associated with PFAS treatment, which involves fluorotelomere-based side chain polymers. Yeah, so these fluorinated polymers are formed of C6 carbon 6 side chain. So we expect that these fluorotelomere alcohols are basically indication of the use of fluorinated polymers in our samples. Next one. With the organic fluorine mass balance calculation, we were able to compare the organic fluorine identified in our analysis of 55 targeted Pfas and the total organic fluorine concentration. And from the calculations, it's clear that on average, it's only less than 1% of the total organic fluorine, which is associated with the specific 55 Pfas. The majority, about 99% of the total organic fluorine, stayed unidentified. So despite of the analysis of 55 compounds, majority of Pfas stays unidentified. Next one. And my last slide reflects the results of bioassay analysis, and which was performed on the subset of 17 samples, and 11 out of those 17 samples actually showed some significant thyroid hormone transport disruption in this in vitro method. It was expressed in PFOA toxic equivalents. And what was actually interesting about those results, that the potency to disrupt thyroid function was not correlated with either total organic fluorine or concentrations of targeted 55 Pfas, which definitely raises concerns about toxicity of the unidentified proportion of Pfas in our samples. Yeah, and with this, I am giving the floor back to Juliet for concluding remarks and recommendations.
Thank you very much, Ika. So to summarize a bit from the key findings we had from our study. So the first one really is to say that we found that the use of PFAS to treat food packaging is really quite common practice from global fast food chains, such as we found samples in Subway, in McDonald's, in KFC, and Dunkin' Donuts from different countries in Europe that were all treated intentionally with PFAS. It's usually the sort of paper bags like you can see on the photo, or also wrapper for burgers, but not only. But we also found some food packaging sample that are used for fast food that are not treated intentionally with PFAS, which shows there are other ways to package this food for these companies. The second really key result is that this use of PFAS in food packaging is not limited to fast food. Actually, the sample in which we found the highest level of PFAS were the compostable sample made of molded plant fiber. So, and this sort of container, so it's a bowl or the clamshell sort of containers, which are being sold as sustainable alternative to single-use plastic container. And as you can see on this photo, so they're really sold as, here you can read people, go natural, compostable. But really it has to be stressed that the high concentration of highly persistent, non-degradable, harmful PFAS chemical in them really contradicts this claim of compostability and sustainability. So there have been really a big loophole here that allowed the presence in such high concentration of this chemical in this type of products. And finally, I think the other really key result, which is quite worrying, really, is that we found PFAS in every sample we analyzed, either with total organic fluorine on some of PFAS or with a targeted PFAS analysis in all the samples, even the samples which are not been intentionally treated with PFAS, so such as these pizza boxes on the photo here. And which means that there is, from at least the sample we analyzed, none of them were truly PFAS free. And this highlights the pervasive contamination of the production and supply chain of the food packaging. And in a way, this echoes the global contamination of PFAS in our environment. So from this study, and really this is really our key message from that, is that for us really the use of PFAS in disposable food packaging is unacceptable and unnecessary. So it's unacceptable because the PFAS pollution, which is being generated by their use in these high turnover, single-use items, will last for generations and impact both people and wildlife. And also, we think that the treatment of disposable items with highly persistent harmful PFAS chemicals is a typical example of an unnecessary and avoidable chemical use. So what do we do from here? So here is good news from our study is that regulation works. So in our study, we sampled exactly the same item was a French fries bag from the brand McDonald's. We bought it in 3 different countries with different national regulation regarding the use of PFAS in food packaging. We bought sample in Denmark, where there have been a ban on the use of PFAS since July 2020, and in the Czech Republic and the United Kingdom, where there is no local regulation. And our results really are striking. Is the Danish sample at the lowest level of PFAS in all the sample we analyzed, and is way below the 20 milligram threshold that Yitka mentions. And so, which means there has been no intentional treatment with PFAS for this one. And on the opposite, the 2 samples from the Czech Republic and the United Kingdom, both at high level of PFAS, which are consistent with an intentional treatment of the sample. So this shows 3 things. It shows that first, the companies have double standards regarding the use of PFAS in their food packaging and depending on local regulation. And that secondly, really regulation is the strongest incentive for the companies to move away from the use of PFAS. And it also shows that once regulation is in place, companies have been able to find alternatives to comply with the regulation. And so the good news here is that there are more places which are banning PFAS in food packaging. I think so far there are 5 states, US states that have also banned PFAS in food packaging. So really, in our view, then this is our key recommendation. We think that to protect present and future generation of people and wildlife from exposure to all PFAS chemical, all PFAS should be banned as a group in all non-essential uses, which includes food packaging as a non-essential use. Because such a group, PFAS group restriction, we think is the most efficient way that will stop regrettable substitution, which is when PFAS is being replaced by another one once it has been regulated, and also really prevent further accumulation of PFAS in the environment and our body by minimizing all emissions from PFAS. So currently there is a process that's been initiated at European level to restrict all PFAS as a group. And our recommendation for this European restriction is really to include all the full range of PFAS chemical, including fluorinated polymers. We've heard as well that in Canada has announced plans to manage PFAS as a class. And really from what I mentioned in the introduction, the PFAS contamination, the PFAS crisis is a global crisis. And ultimately we'll need a global ban to address this. So to conclude this presentation, we have some recommendation for our citizens so regarding what can be done right now. So the first one would be to ask your national government to phase out all non-essential use of PFAS chemical. But also urge companies to phase out PFAS from the products sold in your country. And spread the word on social media so more people know about that. You can use, for instance, the hashtag #BanPFAS. And finally, in the meantime, because regulation can take some time, we recommend you bring your own reusable food container when visiting fast food chains, bakeries, or takeaway restaurants to avoid being exposed to potentially to PFAS through treated food packaging. So that is all for us. Thank you very much for listening, and we welcome your question and are looking forward to answering them during the Q&A. Thank you.
Thank you very much, Julie and Yitka, for your great presentation and all of your work. While we are waiting for Liz to pull up her slides, I would like to remind you to submit your questions through our Q&A feature available on the menu bar at the top of your window. We'll begin the Q&A session after Liz's presentation. All right, Liz, I'll pass it off to you. I think you might be on mute, Liz. Liz, I think you may be on mute.
I'm very excited to have found my unmute button, which hides when you share your screen, a new thing for me to learn about Zoom. Thanks for inviting me to be a part of this webinar. My name is Liz Hitchcock, and I direct Safer Chemicals, Healthy Families, and I am not on the technology team. We were established in 2009 to build support for public health protections in the reform of federal chemical policy. And Safer Chemicals, Healthy Families, and our Mind the Store campaign are programs of toxic-free future. So when I say we in this presentation, I'm not intentionally trying to confuse you. I'm generally talking about the work we all do together. As we worked to build support for reform of the Toxic Substances Control Act, which is the US premier policy on chemicals, we kept hearing the chemical industry complain about what they were calling retail regulation, meaning that big retailers like Walmart and Target were beginning to respond to the concerns of their customers about chemicals like phthalates and bisphenol A by telling their suppliers that they didn't want products that contained those chemicals on their store shelves. And unlike passing a federal law, they didn't need 60 votes in the US Senate to make that happen. So we organized the Mind the Store campaign to help guide that retailer regulation and drive classes of hazardous chemicals out of the marketplace. When we first started working on PFAS chemicals in 2017, most of the people we talked with didn't know what PFAS stood for. And those few that were in the know thought that it was mostly a problem of firefighting foam. They had no idea that we were talking about a family of thousands of separate chemicals, and that one of the most common uses that people were exposed to forever chemicals from was in our food packaging. And by the way, I like Julie's slide better on this. We've since released a number of reports on PFAS in general and food packaging in specific, and I wanted to highlight this recent study published in a peer-reviewed journal, Environmental Science and Technology, that is our addition to the science case for getting PFAS out of our environment. Toxic Free Futures science director, worked with scientists at Indiana University, the University of Washington, and Seattle Children's Research Institute to test breast milk from 50 first-time moms in the Seattle area. And our testing showed PFAS in 100% of the samples that we collected. So 50 out of 50 women tested positive for PFAS, with levels ranging from 52 parts per trillion to more than 500 parts per trillion. We tested breast milk samples for 39 different PFAS, including 9 current use compounds. And a total of 16 PFAS were detected, with 12 found in more than 50% of the samples. The levels of PFAS that are currently in use in a wide range of products are rising in breast milk. Results found that both current use and phased out PFAS contaminate breast milk, despite the claims to the contrary about current use PFAS. I want to make clear here that we don't want to say that women should not breastfeed if that's available to them. The message is that we need to continue the work to get PFAS out of the products that we use, the places where we work, the environment where we live, if we're going to stop contaminating our bodies with these toxic chemicals. One of the tools in our toolbox is an annual report that we release that we call the Retailer Report Card, or Who's Minding the Store. We began 5 years ago evaluating the 11 largest retailers. We meant to do 10 and then we found 11, and have grown to a scorecard of 50 retailers over a dozen market sectors. We use this report card to challenge retailers to get hazardous chemicals off their store shelves and to track their progress against retailers in their sector and individually from year to year. And we're driving progress. The 11 retailers we evaluated 5 years ago have moved from an average grade of a D plus to an average of B minus in this past year's report. Another report that we've recently released in 2018, we researched and released a report that looked at the likely presence of PFAS in food packaging at grocery chains. Our researchers tested 78 food packaging samples from 5 of the largest US grocery store chains. Our study came at the time when these chemicals were increasingly under scrutiny by government regulators. Washington State and San Francisco were the first to ban PFAS in paper food packaging, and New York was requiring its state agencies to give preference to PFAS-free food packaging when it was making its purchasing decisions. Our study, Takeout Toxics, PFAS chemicals in food packaging, found nearly 2/3 of paper takeout food containers, like those used at self-serve salad and hot bars, contained elevated levels of fluorine, indicating they were likely treated with PFAS. 11% of bakery and deli papers tested were also likely treated with PFAS. In response to the report, Whole Foods Market became the first American grocery chain to publicly commit to remove PFAS from some food packaging, including its takeout containers. Trader Joe's, which was not in our report, announced its planned action the day that we released the report. Ahold Delhaize, which is a parent company for 3 big US grocery chains, which had received failing grades in both our 2017 and 2018 report cards, announced its new chemical policy in September 2019, including a ban on PFAS chemicals and the entire class of PFAS chemicals. In early 2020, Taco Bell, the 4th largest fast food chain in the United States, the largest server of burritos and tacos, with more than $10 billion in sales in 2019 at more than 7,000 locations, announced a global sustainable packaging initiative that would ban PFAS, phthalates, and bisphenol A from its consumer-facing packaging. One more report that has netted some positive impact is a report we released last August on packaging from both fast food and some healthier choice fast casual chains, where we tested for fluorine content and therefore likely PFAS content. As you can see, from the burger wrappers to the French fried bags to the salad bowls, we found PFAS in the packaging at both types of restaurant. In fact, nearly half of all takeout food packaging we tested from multiple popular food chains likely contained PFAS chemicals. At all 6 food chains we sampled, our testing showed 1 or more food packaging items that likely contain toxic PFAS. We found that as top burger chains churn out meal after meal, they may be making a significant contribution to the PFAS pollution crisis. At least 1 packaging item from every burger chain appeared to be PFAS treated. And interestingly, 6 of 7 burger and sandwich wrappers were likely not PFAS treated, which shows that the alternatives are out there. But the wrapper on Burger King's iconic Whopper and the thin cardboard container for McDonald's popular Big Mac tested above the screening level for fluorine. Moving to the health conscious chains, every single molded fiber container in our study tested above the screening level for fluorine, suggesting PFAS content. These containers actually showed the highest levels of fluorine out of all the items that we tested. And that includes the Freshie salad bowl, the sweet green bowls for salads and warm bowls, the kava bowl for greens and or grains, as well as the kava compartmentalized tray for kids' meals in the center of your screen. While molded fiber packaging has been prized for its compostability, our testing strongly suggested PFAS content. Leading up to the release of our reports, our staff communicates with the retailers whose packaging we've tested. To its credit, before we released the report, Sweetgreen announced that it would phase PFAS out of its bowls by the end of 2020, replacing them with a compostable bowl that didn't have PFAS. Again, not all of the samples we tested came back with likely positives for PFAS treatment. So we know that restaurants can turn to alternatives to package their products. And we continue to work with the biggest chains to work toward their transitions. PFAS chemicals are again commonly added to paper and fiber-based food packaging for grease and water resistance. And it's hard to tell which packaging contains PFAS and which does not contain the chemicals. So we've developed new guides for grocery and quick service restaurant chains. The guides contain straightforward steps for chains to make sure their food packaging does not contain PFAS. And our new guides will help chains to find a clear path to adopt and implement policies to go PFAS free. You can find this fact sheet that I've just turned to on our website, and we share that in meetings as we meet with retailers. We also maintain a living document on our website that identifies alternatives and companies that make them as our researchers find them. Both, again, can be found if you go to our website at saferchemicals.org. After we released our report, we heard from commitments from additional popular food chains, and I don't want to leave anybody out. But one thing to note is that when we got the results from McDonald's, we launched a public campaign to call on them to go PFAS free. Now, McDonald's is the largest food chain in the world, serving an average of 25 million customers every day with an annual revenue of $21 billion in 2019. And there are more than 38,000 McDonald's restaurants worldwide. So it's a pretty good deal. And to give you a flavor of our campaign, in the 6 months after we released our test results, more than 70,000 people across the US took action and signed petitions calling on McDonald's CEO to ban PFAS in food packaging. Advocates visited dozens of McDonald's locations around the country, telling the company, we're not loving it. And learning and developmental disabilities organizations in more than 20 US states sent McDonald's a letter calling on the company to ban PFAS in their food packaging. Investors filed a shareholder resolution in December asking the company to disclose its actions to address the possible public health and environmental impacts of toxic materials in food packaging. And it seems to be working because in January of this year, McDonald's announced a new global sustainable packaging commitment, banning the class of PFAS from their guest packaging materials within a couple of years. We also had commitments from Amazon, 7-Eleven, and Panera. And in addition, in April, one of McDonald's biggest rivals in the burger wars, Wendy's, announced that it would eliminate PFAS from its consumer-facing packaging in the US and Canada by the end of 2021. This is our snapshot of the commitments that demonstrate that we're driving market leaders to take action on PFAS chemicals. And I left Wendy's out of this slide, but the numbers of 27 retailers and 71,000 stores and $307 billion in sales feels pretty good, and demonstrates that all in all, we're having a pretty good run, but there's still more work to do. We've focused on the biggest chains by sales volume. And while we've won commitments from the 5 of the 6 chains that are studied in our report, it's hard to forget the king. So we're campaigning to get them to take action. And while we've seen some recent progress, we're not ready to call it a wrap just yet. We've worked with shareholder allies to send a letter to Burger King in advance of their recent shareholder meeting. We did a national call-in week with volunteers expressing concern about their use of PFAS. And at their shareholder meeting last month, the CEO said, and I have to quote here, "Our procurement and brand teams are looking at several alternatives to still achieve the leak barrier that we want without using PFAS chemicals." So we're getting there. And just in case they don't act, a new activist has joined our campaign. Allow me to introduce you to our newest organizer, Polly, Polluted Polly, who reminds us that they might call it fast food, but when lunch is over, there's still an aftertaste of pollution from these forever chemicals. And Polly's pretty darn steamed at the path of pollution that's caused by PFAS, and Polly's going to get around this fall, bringing the message that we should take PFAS off the menu to communities across the country. We're proud to have won these voluntary retailer commitments, and they're helping to push policy change in the states. Since Washington State and San Francisco led the way in banning PFAS in food packaging, they've been followed by Maine, Vermont, Connecticut, Minnesota, and my home state of New York. Other state legislatures are still in session, and there may be legislation passed in additional states this year. But just as markets can't do it alone, states in the US can't protect us all. It matters a great deal in the marketplace when multiple states take action, but the restaurants that are buying packaging to serve their food in deserve the assurance of a national requirement, and their customers definitely deserve that confidence. So we continue to work to pass a federal law, and Polly's going to Congress. The federal government has an important role to play here to get PFAS out of food packaging from sea to shining sea. And so in addition to Polly, we'll campaign with some regular people this year. All of our work in the markets and in the states has paved the way for the federal government to act. Representative Debbie Dingell of Michigan, who has responded to her state's substantial experience with PFAS by really taking action on these forever chemicals, sponsored a bill to ban PFAS in food containers in the last Congress, and committed yesterday at a conference to reintroduce her bill by the end of this month. We're going to take the momentum that we've won in the marketplace and in the states to Congress and urge them to send the bill to President Biden's desk this year. I'd like to take a moment here to thank the organizers for inviting me to present here, and thank all of you for your attention. Let me stop here and make sure we have some time for conversation, and thank you again.
Great. Thank you so much, Liz, for your presentation and for the great work you're doing as well. This is exciting news. I just wanted to remind everyone, feel free to put in questions in the Q&A, and we will be heading into the Q&A session now with Shannon leading the way. Shannon, I'll pass it over to you.
Thank you very much, and also for the excellent presentations. There's just so many things to dive into here, and one question that has come up in the question and answer is about how, we've heard that some retailers are replacing PFAS. So what is replacing PFAS? And if we know that it's safe? And I don't know if one of our panelists would like to answer that question. Who would volunteer?
I can go ahead.
Great, Jitka. Excellent.
Yeah.
Thank you.
Yeah, so we know that basically there can be plastic foil oil used on the surface of the material, but then it's very hard to separate such materials one from the other. So it then makes some barrier to the recyclability of the item. The other option is to use wax on the surface. Vegetable parchment is also another option. We also found silicone coating on the products, And among our samples, we had cardboard pizza boxes. And actually, only the material and mechanical solution is giving enough function to avoid leaking of the fat through the packaging. Yeah. So with the pizza boxes with only very small background contamination of PFAS, we may say that also the simple cardboard is an alternative to PFAS treated paper. I don't know if Julie or others want to add a word to this.
No, thank you. You responded very well, Shika. Thank you.
Great. I think that's important to bring out, that they're all alternatives. So we can get as take PFAS off the menu. I really like that. That was a great from Liz. So moving on to another question around how do these PFAS in packaging contaminate the food exactly? And how do we explain this to the non-science person? How are they absorbed into the body? I don't know if anyone would like to, who would like to take a stab at that one? Yes, go ahead, Julie.
So, so first, the thing that the PFAS used in the food packaging, there can be different ones. And as we show for our samples, most of them probably polymeric PFAS, so sort of plastic PFAS in a way. And this one won't migrate, there won't be no migration, but it will be the free PFAS, the one maybe the impurities in this treatment or other type of PFAS. So for instance, in the one we've detected, PFHXA, it's a sort of PFAS that will potentially migrate into the food. And it happens mostly when the food is really fatty or rich in protein, which is what favors the transfer from the packaging into the food. And then if it's ingested in the body, and some PFAS which can be, say, bioaccumulative, so they can stay in the body for a long time. They tend to stick to protein, to bind to protein in our bodies, and so if we keep repeat the exposure, we could then build up a certain level of PFAS in our body, which is when it starts to be of concern. If it's just exposure just for one time, it's going to be okay. It's more, it's the whole issue really with PFAS is that how much is building up with time.
Thank you, Julie. Yes, Liz. Go ahead.
One of the things that, and I did really like Julie's slide about what we call the path of pollution for PFAS in food packaging, that we're not just talking about the time when the wrapper is around the burger and like many American teenagers, I've done my time behind at a McDonald's drive-through, and I remember the speed with which you move the product. The packaging, the production of the packaging or manufacture, to the use of the packaging and the use on the burger, and then the disposal of the packaging, all contaminates the environment and has this path of PFAS pollution. So I think it's important that we remember that it's not just the time around the burger before you eat it, or the time that the salad is in the bowl and the food is touching the packaging, but that it is all along the path that we are exposed to these chemicals.
Thank you.
You are muted, Jenna.
You are muted, Jenna.
Sorry. Okay. Yeah. Moving on to another question, and this is, I think, more for Liz again, about, because you've explained to us how companies are moving away from PFAS to non-fluorinated alternatives. How can we ensure that these alternatives are truly safe and more eco-friendly, sustainable? And are there US companies making non-PFAS packaging?
Well, I pointed out,
just to remind
I pointed out in my presentation that we maintain a couple of fact sheets that we share with retailers as we do the testing and publish the testing. We wanted to meet with the company, the fast food restaurants, sustainability officers, to talk with them about moving from a packaging line that contained PFAS to safer alternatives. And I'm very appreciative of the idea that we don't want to jump from the frying pan into the fire with what are regrettable substitutes. So we do maintain this fact sheet on our website at saferchemicals.org, where we're keeping the list of alternatives to PFAS. So if you want to serve in a bowl, we keep track of the alternatives, and it is it is a place where it's a growth industry, as more companies are wanting to respond to the demands of their customers who say, I want a salad, but I don't want to get a salad in a bowl that's treated with PFAS. So what can you do? And we urged people to call McDonald's, call Burger King. People on their own will call companies and say, what are you making? What are you serving my lunch in? Because when lunch is over, the chemicals are still forever.
Thank you, Liz. And another question we have is around, are there studies that show that exposure levels one experiences from eating food out of PFAS treated takeout containers? And is there high enough exposure from this method that consumers should be concerned? So would either maybe Jitka or Julie want to answer that one?
Yeah, fine, sure.
Great.
You can go ahead, yeah. Yeah, we know migration rates of some of the PFAS. For some other, which are not identified, we can only guess. So it's hard to know. Consumers should not be super concerned that they will get poisoned after using one burger bag for their lunch burger. It's not the case. I think that the larger concerns are on the end of the pipe. Yeah, so when all these packaging materials are being disposed, and they are disposed in large amounts. Other concern is the beginning of the production chain, when all the PFAS are being produced, and we know the evidence is showing really vast contamination of the surrounding environment of the PFAS manufacturing plants, and these cases are also known to contaminate drinking water sources. Lots of high concern from consumer point of view. Yeah, so for me, more looking at the entire life cycle than only the angle of migration into the food and contamination of the body when eating the burger from the
Thank you, Jitka. And I have, I think I can have time for one more question. I know we're getting to the end, and this is around, very interesting that you said, Liz, that the U.S. is, Senator Dingell is going to introduce federal legislation on PFAS. And I also know that the EU, you mentioned in your presentation, is looking at a group restriction. So I wondered, what are some of the key things that you're hoping for particularly the EU group restriction that's going to take, that's actually in the making now? And maybe Julie or Jitka would like to answer that. And what's the timeline? Do we know when this is going to happen? So we know we heard from the US federal is happening maybe hopefully by the end of this year. So Julie, give us some hope.
Yes, yes, some hope. So at Chopin, I think it was actually today that 5 member states in Europe, so that announced they will work on a group restriction on PFAS. And today, I think they registered the intention of the restriction officially with ECHA, the European Chemical Agency. And from there, so then we know a bit more about the timeline. It takes a year to prepare the dossier for a proposal, and then at least a couple or 3 years to go through the full process before a final vote to accept the proposal and to come into force. And in terms of from our side, what we hope from it is that really the scope in terms of what PFAS are covered with the restriction is as large as possible, because it's really what we need to reduce the emissions, and so to avoid as I mentioned before, the buildup in the environment, and because it's really a question of generational matters as well, and fairness, because it's the pollution we create today, it's going to be there for generations to come. And so the widest scope as possible to really grab all the potential emission, and also a widest scope possible in terms of uses. And there have been a proposal to allow only uses in what's called essential uses, and this topic maybe has been covered in this webinar. It's really interesting, which is really to think, and it's quite common sense that you can recognize that can bring benefits in some application to society, but yes, in that case, let's get rid of all the frivolous uses, such as in food packaging, as we mentioned.
Thank you, Julie. And I just give Liz the chance to answer. I see you like to jump in as well.
One thing I wanted to note about Representative Dingell's bill is that the bills have passed in states this year, and the bills that have passed in most of the states have been bipartisan votes in favor of these bills, which I think is a good recognition that this is not a partisan issue in the US. And so I'm encouraged that Representative Dingell plans to reintroduce her bill because I think that PFAS hasn't known party, and we can protect all Americans from these dangerous forever chemicals in our, at least in our food packaging and in other non-essential uses.
Thank you very much. I'll hand it over to Hannah to take us to the end, and great presentations and questions and answers. So thank you, everybody.
Great. Thank you so much, Liz and Yitka and Julie, for your presentations, and to you, Janan, too. We're approaching the end of today's webinar. A video recording will be available on CHE's website soon, and tomorrow you'll receive an email containing a link to the video. The CHE EDC Strategies Partnership webinar is one in part of an ongoing series of PFAS science and policy. We will host the next webinar in the series on hopefully coming up soon as new things progress in the news and in the science and in the policy. On July 20th, CHE will also host a partnership webinar on the science on toxic chemicals in the built environment, environmental health disparities and equity-driven solutions. Then on July 27th, we will host our 8th and final webinar in our Generation Chemical Partnership series titled Climate Change and Reproductive Health. You can find details on our website at healthandenvironment.org. If you are new to CHE and would like to stay updated about upcoming events or more, please sign up to receive our newsletter by selecting the Join Us tab at the top of any page on our website at healthandenvironment.org. Additionally, if you appreciate these CHE partnership webinars bringing you the latest environmental health research for free, we encourage you to support CHE's ongoing work by making a tax-deductible donation via our secure website at healthandenvironment.org. With that, I would like to thank our speakers, Julia, Yitka, and Liz, for taking time to present today, and to you, Janan, for your excellent moderation. Thank you so much for joining us. We're wishing everyone much health and wellness, and have a great day.